let's talk about what we're looking at here. You recognize him?
Yes.
Yes, he is. Good. That's the average of our sample of 5 values. Do you see our sample size of 5 anywhere?
Yeah.
Right there. That's good. Keeps track. That way you know if you made a data entry error. If your n says something like 8, you'd be like, oh, that's interesting. So I could have looked at that too. Your n value was much larger than 5, which means there are more data points in it. So that's one way you can check to make sure you didn't make a data entry error. Make sure that your data size matches that. That's the average 81. Thank you. What's this? Good! Which means we'd have to add up all of Ernie's points on all of his tests. That divided by that is equal to that. Yeah, I don't understand why TI still puts this here. It doesn't make a whole lot of sense, but it's fine. It comes in handy occasionally. As long as you know what you're looking at. What's this? This is if you took each of Ernie's exam scores, squared them, and then added them up. It's called the sum of squares. You'll never use it here. You'll never use it here. Because that is 32,815 squared points. I don't know what the hell that means. Doesn't matter, you're not going to use it. What's this? This is your friend, yes? These two guys right here we spend a lot of time with in this class. That is what we spent all this painstaking calculation doing to get to that 1.6 points. That's right there. Beautiful. That was the whole point, was to get to that value right there. Sorry, what was that 1.6 again? 1.6 points is what? It's sample standard deviation. Good. It's a sample standard deviation. That's what it's called.
Average distance from the mean.
Say it again, Aaron. Nice and loud, please.
The average distance from the mean.
Excellent. That's what the sample standard deviation is. On average, it's how far the data points are from the mean. On average, how far the data points are from the mean. Fair enough so far? You're making sense? Now, the calculation gets a little bit gnarly, but the calculation is taken, well, you can't see it right now, it's taken care of right here for you. Do you see this one right here? This little guy right here?
Yeah.
He would be the result. Remember back there, this is a step I think you all started hating me. Remember when I said you don't divide by 5, you divide by 4? Right? If you divide by 5, it's this calculation right here. Now, we are never going to use this in here, at least, well, I shouldn't say never. We're not going to use it for a while in here. This is the Greek lowercase sigma. That little symbol right there, it's the lowercase sigma. Uppercase sigma is this guy. When you see uppercase sigma in statistics, it means you're adding up all of whatever you're adding up. When you see lowercase sigma in statistics, it means you're dealing with the population standard deviation. Why do we pretty much assume that's fiction? Why do you pretty much assume the population standard deviation is fiction? Why is this class called statistics?
Population's always changing.
Well, that's one reason. But even if it was static, what's the problem with trying to measure a population directly? Sure, but suppose we can control for them. So suppose we actually gave let's make up an example. Make up an example. Not Bert and Ernie for make a real example. You have a new drug that treats ADHD symptoms. Treats ADHD symptoms, and you have a claim. You have a claim that you think your drug increases cognitive capacity by 10% over a competitor's drug. Where did that 10% come from? A sample that you drew. Now, if you actually wanted to make a bomb-proof claim, what would you have to do? Give your drug to every single ADHD person in existence. Even assuming that they weren't changing, living, dying, becoming ADHD, not becoming ADHD. Do you see the problem with that? There are too many of them to do, so you give it to a sample. That's why this class is called statistics and not... Remember what the measure of a population is called? It starts with a P. Parameters. That's why the course isn't called parameters. It's called statistics. This is a parameter right here. Population standard deviation is the actual population, the variation in the population. That's fiction. That assumption means that the 5 data points you put in are your entire population. It's ridiculous. You see why I'm getting so upset about this? Hopefully, maybe not. Maybe not. It's okay. Just ignore it. because you very rarely have an entire population. You do have a sample though. You do have a sample. And that's why I like this one. I like little s. He's a big fan of little s. Big fan of little s. Can't stand little sigma, talk about little sigma generally. Sometimes you can. And we'll talk about why later on in this course. But right now, it's ridiculous to talk about. It doesn't make any sense. Statistics. This is x bar. That's a sample average, isn't it? Only makes sense. You pair with the standard deviation. Shouldn't pair apple with an orange, apple with an apple. Okay so far? So you can ignore that. You can ignore that. Hey, check this out. See that little arrow right there? Scroll down. What other goodies you got? There's some other goodies in there. Some other goodies in there for sure. You've got your min and your max values, which you can figure out pretty simply in a small data set, but in a larger data set it might not be as obvious. So Ernie's min is 79, his max is 83. You also have his median, which is going to save you guys some time when you have large data sets. Rather than have to put everything in order, it finds it for you. Very nice, yeah. Doesn't give you a what?
Mode.
The only one it doesn't give you is the mode. And there's a good reason for that. And you can, the mode is the least mathematical anyway. It's probably the easiest to find without using technology. So I can live with that. You can too. Don't worry about these Q1s and Q3s. We'll get to that soon. It doesn't make any sense to talk about that right now. It fits better with another discussion. Cool so far? So this is good news for us. This is good news for us because we get these two guys right here essentially for free. I love that. That makes me so happy. Okay? Now, we have a vote of 20 to check though. Remember I asked, what do you think Bert's was? Zach voted 20. Anybody else have other votes that want to throw out there for Bert? 7. 12. 7, 12, 20. 8. All of you are guessing higher than 1.6. I think that's fair. It should be higher than 1.6. Now, do we have to go through this calculation again? Hell no! Start the camera, start it up again. Go back.